Hey guys, today's trek into DIY tech is one that some have been waiting for a little bit. It's going to be a look at our Aquatic Rover. And I'm sorry if you see me sweating a little bit. It is hot as Beelzebub's underarm out here. But we're going to do the video anyway. So come a little closer and we'll take a look at what's inside of this thing. So if you're taking a look around the outside of this thing, you can see that we have our AV antenna here, and that's connected to this camera here, and this is just an FPV camera. We also have the telemetry radios antenna here, and just on the outside mechanically we have some pool noodles. Anybody? Yeah, you guys know what that is. I don't have to explain that. And here we have the two thrusters. I'll put a link to the video for testing those thrusters in the description. You guys can check that out. But yeah, we had these two thrusters that I custom made for these applications that we're working on. And right here we have an action camera. We got the action camera set up so that we can put this camera in there and we can get some underwater shots. We also have a twin of that on the top, and well, not exactly a twin because this one's it's screwed into there, whereas the one on the bottom has facility to be screwed into that T there. The reason there's a T there and it just doesn't terminate into just a something like this is because we want to run wires through here for sensors. So we're going to be doing some conservation work or some citizen science work where we're going to take temperatures and correlate those with the pictures that we take with the action camera. So we're going to timestamp everything, and we're going to correlate GPS, picture, and temperature readings. So that's going to be something that's going to be handled by, now we're going to go into the inside. And if you notice, this construction is just like the water rig for the action cameras that we did before, and also shares similarities with our submersible action camera rig that we did before. And that one's powered, so it's very close to Sea Perch design, but a more compact version. So if you look inside here, now we're going to take a look at, this is our GPS setup. So this just gives us a location based on signals we get from satellites or satellite constellation. And we're going to keep this video very high-level overview, just to give you guys an overview of what this is, and then we'll split up the rest into, the detailed view of the components in other videos, so that we don't, make this video too long. But I'll just go through everything real quick. GPS setup. This is our telemetry radio, and it lets us hook up to things like QGroundControl. So this can be on a laptop or, as you can see, the cell phone. And we can connect and we can run various functions on here. And we can also monitor its actual GPS location as it tracks along. So, and again, that comes out of this antenna here. And moving right along, we have the video transmitter. This can transmit video and audio. Later on, we're going to be able to switch between all three cameras with a switch that's controlled from the RC controller. Right on the side here, we have the RC receiver, which lets us use a controller like this Radio Master here. And this controller will let me, when I want to take manual control, I can just switch over to manual, and I can actually go ahead and pilot the Aquatic Rover manually. In case it gets into trouble or I can't figure out where it's going, GPS goes out, I can just drive it back to myself. So, and these are just some tail antennas that are in there. This is our flight controller. This is the brain of the whole operation. Well, it's the pilot anyway. We have another brain here, which this one is going to be hooked up to a real-time clock. Some circuitry here that's going to go, again, it's going to go down through there. We'll take this plate off so you can check it out, but it's going to go through the tube that goes under here and right to the sensors at the bottom, as I showed before. So this isn't hooked up yet. Again, that's left for another video, because we're just doing an overview here so you guys can get an idea of how the system is set up. We'll also show you a block diagram at the end, and I'll step it through with all these wires in the diagram, so it looks less like spaghetti and it's easier to see. This guy right here, piezo buzzer, that's going to give us some feedback from the flight controller as to what state it's in. So when we arm it with this button, we'll get a beep code here, and we'll audibly know when the flight controller is ready to go or something's wrong. So yeah, let me unscrew this plate here, and I'll show you what's under there. All right, so that plate just comes off in one piece, makes it easy for maintenance and what have you. So here you go. As you can see, all the cables for the motors go down that way, and that just goes down this tube and right to the thrusters on each side. Makes it real simple to wire everything up. But we have 220 amp ESCs here. So that should be plenty of power to run these motors here. And if you watch the thruster test video, you'll see just how much power these guys can put out. This is our micropix. In the future, we're gonna probably move to an M Robotics flight controller for this, but this is the same type of flight controller that you would find in your average quad rotor drone or your Hex drone. This one actually has up to 8 motors that it can control on these outputs. GPS comes in, RC control comes in, telemetry goes out. This particular flight controller, very cool, has 2 telemetry outputs. So what I can do is I can connect that second telemetry output, actually connect that to the Arduino that we're going to have on board running the science tests. So that we can sync up the clocks, we can sync up GPS, all of that through a what we'll look at later as well, a Mavlink subscription. So what that just means that the same information that's coming out of this telemetry here, we can send it to the second telemetry port. The Arduino can read it and act on that information. The other thing that we have is a 5-volt BEC. So this takes the battery power. So this is our battery here, and this battery, it should provide plenty of juice. We have actually a 5200 milliamp hour. That's pretty. That's going to be more than enough power for hours of powering around in our waterways to collect all this data that we're gonna collect. And those are directly connected to these ESCs, but to run the flight controller we need 5 volts. So that's what this 5-volt BEC is, BEC. It's just a battery eliminator circuit. And then we have some additional circuitry under here. There's a power distribution board, which you'll see in the block diagram in a little bit. That power distribution board, all it does is distributes the power. Comes from the battery here, goes through the power distribution board, and it gives us a voltage and current reading. So we know how much voltage and how many amps we're using up as we're driving around, so we can, make this system better as we go, right? We can make it more efficient, and we see, make a change and see if we're actually getting more efficient or not. Yeah, that's about it. We have the 9-volt back. So we also have another back. These are adjustable. So we're getting 5 volts here and 9 volts here. This one actually runs our Arduino circuitry. So we're going to be plugging into this guy, and we're probably going to have some switching circuitry here so that we can turn the brain on and off remotely and things like that. But the Arduino is going to be running off the 9 volts, and any 5-volt circuitry on here will be running from the this Arduino has a pretty robust regulator here, and it's fused. So we're going to be using the 5 volts from here versus the 5 volts from here. So we isolate the two 5 volts. Something goes wrong here, we don't want that affecting our flight controller. So yeah, so that's pretty much the full overview. So the video that we're going to be getting back from the FPV camera, we have a nice receiver here. This is also what they call a DVR, or a digital video recorder. So we'll have our SD card plugged in there. This is nice little self-contained 5 megahertz. And so that'll go from here to here, and it has a pretty good range. So we'll be able to see as we're driving along. If we need to take manual control, again, we'll be able to do that and see where we're actually headed. But that's it. That's it for the overview. Now we're going to go to the block diagram and show you what that actually looks like. Probably the wiring will be clearer as you see in a moment. Okay, we are having a pretty good thunderstorm outside right now, so sorry in advance if it gets bad. But here we go. We're going to go over this really quick, and you've already seen all these components. So I'm just going to step you through this block diagram. Usually I create block diagrams for all the projects, and just to lay out how everything's going to get connected, and just to remember what the scope of the project was and things like that. Subsystems are not here, so it stops at the Arduino Uno. You're not going to see the sensors or anything hooked up here. That would be on a separate page for that subsystem and so forth. So you're going to see just what's inside that case right now. And as you can see here, we're going from the battery to the, and this may be a little bit hard to see because the lettering is going to get small, since this is an 8.5 by 11 size page. But I'm going to point to everything, and if you're following that arrow, you're probably getting motion sickness. I like to share. I always get motion sickness when I'm watching somebody else move around on the screen. But here we go. So LiPo battery, again, that goes straight to the power distribution board, and these are color coded. So this is circa 11 or 12.6 volts when it's full, and just under 11 when the battery's low. So 11 volts in there, goes through the power distribution, again gives us current and voltage, and it gets distributed out to the BEC. BEC turns that into 5 volts, and it goes to the flight controller. From the flight controller, the 5 volts and signals get distributed to the GPS here. It goes to the telemetry radio and the safety switch and buzzer. So all the essential components, they get 5 volts from the flight controller there. And if you go to the other side and you look at these ESCs, what's running the motors, the brushless motors on the thrusters, you're gonna have full battery power going into the ESCs, but then again you have signal and 5 volts coming from the flight controller. So the signal side, or the controller side of these ESCs, the logic is 5 volts. So the flight controller is providing 5 volts as well as a PWM signal to tell these ESCs how fast to push these motors. And you may notice here, if you have really sharp eyes, you can see there's a clockwise thruster and a counterclockwise thruster. The reason that is because we're both motors are pushing in the same direction, and they're trying to maintain a plane. But if they were both spinning in the same direction, it would cause a rolling action on the drone, or in this case the watercraft. This wouldn't be as pronounced because this is a surface vehicle, and the surface tension is going to the buoyancy of both sides is going to try to keep it upright. But if it was a submersible, you would see it when you tried to move forward and both props or both motors were spinning in the same direction. You would see the vehicle would twist a bit. And so by having a clockwise and counterclockwise spinning in opposite directions, that counteracts that. They both cancel each other out. So in case you were wondering, that's the reason they both spin in opposite directions. And then we also provide power through the distribution board from the battery to the 9-volt BEC for the Arduino, and it goes to the AV transmitter. And yeah, so the AV transmitter likes 7.5 volts or better. So we're just taking it straight from the battery, and it goes up to 32 volts. So we're pretty safe with a 3S battery, because we're gonna max out at 12.6. And these little triangles here represent our antennae. That's a symbol that's used regularly. I didn't bother using the exact symbols for all of these because at this level, this is a DIY project. If I was doing this for work, I would go through and this would be all the schematic symbols and everything that you normally use in the industry. But for block diagram to show you guys how everything's connected, this suffices. So I hope that cleared up the wiring a little bit, because it really does look like spaghetti when you look at it, when you open the cover and just look at it that way. And I'm going to move the cursor out of the way, so if you need to freeze this and take a better look at it, you can go ahead and do that. I'm going to try to add all of this on the website, create a page strictly for the Aquatic Rover, so you guys can get a resource page, so you guys can pull the documents like diagrams like this and everything that I generate during the course of the project. And yeah, if you have any questions, put them in the comments, and as always, we'll try to get to them as soon as I can. So all right, guys, that's it. I hope you enjoyed that one. And again, if you want to help us keep these videos going, like, subscribe, share with your friends and family, or share with everybody. And we'll keep making the videos. And as I said, we're gonna try this new format where we do an overview first of the project, and then we'll split all the different sections of the project: mechanical, electronic, and software. And that way, the videos aren't so daunting to watch. It'll be broken up into chunks that are easier to digest. And yeah, check out some of our other overviews, and let us know if you want us to continue any of those projects there. And thanks for watching. See you in the next video.